Hello students, welcome back to the physics session guys. It seems in the afternoon session you said this part was not visible while I was writing on the whiteboard. So now you guys can go through this. Okay, I will read the questions also here so that you can refer this once again. Level 2 exercise 1. Level 2 exercise 1. Question number 49. Question number 49. Yeah. The question is, in two separate collisions, the coefficient of restitutions E1 and E2 are in the ratio 3 is to 1. In the first collision, the relative velocity of approach is twice the relative velocity of separation. Then, the ratio between relative velocity of approach and relative velocity of separation in the second collision is. Different options are given. First option 1 is to 3, second option 2 is to 3, third option 3 is to 2, fourth option 6 is to 1. To understand that, we have to follow this. As E is equal to relative velocity of separation by relative velocity of approach. General formula is this. In first case and second case we have taken, then we have taken the ratio by as it is given here. And on simplifying these two, we have got 6 is to 1. Then go through that. Then question number 40. You guys said this part also was not visible. Right? Yeah. So question number 40. Let me read once. Page number 47. Question number 40. Level 1. Level 2 exercise 1. The question is. The question is, because why I am reading this is some IIT students also might be attending. For them, they need to know the question because page numbers will be different for them, and the question numbers also will be different. So go through the question guys once. The question is, a body of mass 5 kg moving with a speed of 3 meter per second collides head-on with a body of mass 3 kg moving in the opposite direction at a speed of 2 meter per second. At a speed of 2 meter per second in opposite direction. The first body stops after the collision. The final velocity of the second body is. So I have taken M1, M2, U1, U2. U2 is moving in opposite direction, so I have taken negative sign. Then as the first body stops, what is the speed of the second one you are asked to find? By applying law of conservation of momentum, you have calculated this. Very simple. Then question number 41. Question number 41. See here what is given and what you are asked to find. Question is, let me read the question once. Three identical particles moving with velocities v0 I cap, minus 3 v0 j cap and 5 v0 k cap collide successively with each other in such a way that they form a single particle. The velocity of resultant particle in I, J, K form is. Different options are given. So to understand that, we have taken all masses are identical masses. So m1 equal to m, m2 equal to m, m3 equal to m. And the initial velocities of these are given as u1, u2, u3 as v0 I, minus 3 v0 j, 5 v0 k, and after collision they all combine, they all form a single particle. That means all the combine or stick together and they are moving with a common velocity. So v1, v2, v3 are equal to v. What is that we are asked to find? So for that purpose, we have applied law of conservation of momentum according to it by substituting the values of m's and velocity, initial velocities. We have got this here. By simplifying, by cancelling m, we got this one, v equal to v naught by 3 into I cap minus 3 j cap plus 5 j cap, 5 k cap. Okay, go through it. Next, let us see question number 43. 42 we'll see later. 43 we'll see now. Question number 43. These kind of questions also important, guys. Some of the previous years question, these kind of questions also asked in different exams. So question number 43. Let us see here. Question number 43. Question number 43. See here. And page number 47 only. Right. The question is, a steel ball of radius 2 centimeter is initially at rest. It is struck head-on by another steel ball of radius 4 centimeter traveling with a velocity of 81 centimeter per second. If the collision is elastic, their respective final velocities are. So what is given here? Instead of mass, they have given radius. There is a steel ball of radius. You can take 2 centimeters initially at rest, and another steel ball having some different radius 4 centimeters, moving with velocity of 81 centimeter per second. Struck. This means that one you have to take it as first one. This is second one. Okay. So that means you have to take this as m1, and we have not given m1 m2 guys here. Instead of m masses they have given radii. So no, mass is not given, radii are given r1 r2. Okay, r1 r2. The one which is having m1, let us say having radius r1, and the one which is having mass m2 having radius r2. So it is mentioned that the one which is at rest, let us consider this as second one. Okay, the one which is whose initial velocity is 0, let us consider this as second one. The one which is moving with the initial velocity u1, we consider this as first one, m1, and hence its radius is r1. So r1, the one which is at rest having radius as 2 centimeters, so let us consider this is r2 equal to 2 centimeters. The one which is moving with velocity of 81 centimeter per second is having radius of 4 centimeters, so it is r1 equal to 4 centimeters, so its velocity is u1 equal to 81 centimeter per second, and hence u2 is equal to 0. This is at rest. Then they undergo collision elastically, so that when they undergo elastic collision, perfectly inelastic means they will stick together and move with common velocity. That is what in the previous questions we have discussed. Now this is elastic collision. In case of elastic collision, they will have different velocities. This is before collision. After collision, they may move with velocities v1 and v2. Okay, after collision. So what are v1 v2s? We have to remember the formulae related to final velocities after collision, guys. Final velocities after collision here. And what are final velocities after collisions? In case of elastic collision, we know that in elastic collision final velocities are v1 v2, and they are given by v1 is equal to m1 minus m2 by total mass m1 plus m2 into u1 plus 2m2 divided by total mass m1 plus m2 into u2, that is v1. And v2 is equal to, you have to keep this terms, this here it goes here, this kind of term comes here. That means in v2 u2 term comes as m2 minus m1, and u1 term will come as 2m1 by m1 plus m2 into u1, and u2 term comes as m2 minus m1 divided by total mass m1 plus m2 into u2. But here masses are not given, radii are given. Then how can you handle with this kind of questions? You have to remember that. Because density is equal to mass by volume for a spherical ball. They have given steel balls, spherical balls, right? Steel balls. They will have some volume. So here, this can also be further expressed as this implies mass is equal to density into volume. Because same steel balls only are considering, so steel will have same density, whether it is having different masses or different radii, whatever it is, density will be same for steel. So you can say, from this you can say that mass is proportional to volume, but volume of a spherical ball is given by, you can say, you can write it here, you can write this instead of here itself by taking proportional relation. Let us write this as, this implies mass is equal to density, which is a constant, into volume of a spherical ball is 4 by 3 pi r cube. So 4 by 3 pi is a number, density is also constant, this entire thing you can take it as a constant, then hence you can write mass is proportional to radius cube. Is this clear, guys? Now here onwards we have to replace m with r cube, m with r cube, and hence m1 means r1, m2 is r2, r m1 means r1 cube, m2 is r2 cube, likewise we have to replace here. Then what you will get, this equation can be expressed here itself, can be expressed as m1 is r1 cube minus r2 cube divided by r1 cube plus r2 cube into u1 plus 2 into m2 means r2 cube divided by m1, sorry, r1 cube plus r2 cube into u2. Similarly, this can be expressed as 2 m1 means r1 cube divided by m1 plus m2 is r1 cube plus r2 cube into u1 plus, yeah, write down, write yourself and do it. Try to substitute the values and do it, guys. R1, R2 values are given. Try to substitute this, guys. So question number 43, right? Yes. Then what will you get? This is further, is this term will become m2 means r2 cube minus r1 cube by r1 cube plus r2 cube into u2. Now look into this once. Here initially u2 is 0, right? Now in these relations, keep u2 is 0 wherever u2 is there. So u2 is 0 means this term will become 0, this term will become 0, so this term becomes 0 and this term also becomes 0. So v1 is equal to this, v2 is equal to this. To write down this relations once again and substitute the values. v1 is r1 cube minus r2 cube. This implies v1 is equal to r1 cube minus r2 cube divided by r1 cube plus r2 cube into u1. This is equal to r1, r2 values we have taken them as r1 is 4, r2 is 2 centimeters, okay, substitute them, and u1 is 81. So r1 is 4, r2 is 2, r1 is 4, so it is equal to 4 cube minus 2 cube by 4 cube plus 2 cube into u1 is 81 centimeters per second. Simplify this, guys, everyone. 4 cube 4 cube is 64 minus 2 cube is 80 by 64 plus 8. 2 cube is 8, right, into 81 into 81. So this is equal to 64 minus 8, 60 minus 8 60 minus 8, 52 plus 4, 56. So this is equal to 56 divided by 64 plus 8 is 64 plus 8, 72 into 81. So try to cancel out with the nines, how many times it goes? Yes. Yes, are you working, guys? What happened? It has disconnected or what? Yes. Yes, simplify it and what will get? So V1 will be, on simplifying this, so question number 43 will get 144, will get 144 centimeter per second V1. Similarly, substitute for V2. V2 is equal to, also, or similarly V2 is equal to, what did you get for V2? V2 is 2r1 cube by r1 cube plus r2 cube into u1. 2r1 cube, 2r1 cube by r1 cube plus r2 cube into u1. So it is equal to 2 into r1 is 4. 4 cube is, directly let us write, 4 cube is how much? 64 divided by, already I have taken, right, 4 cube plus 2 cube. Same. What is this? 4 cube plus, can say 4 cube plus 2 cube. It is equal to 2 into 64 by 4 cube plus 2, 2 cube is how much? 72. Hmm? Cancel out and simplify this. What you will get? 2, 3, 6, 2, 6 is 12. um, then, so what will get on simplifying this? 63. What is this? Did you into u1 is there, guys? Into u1. It means into 81, right? U1 is 81, right? Into 81. So 9 fours, 9 nines, then 4, 4 ones 4, 4 sixes, 24. So 16 into 9. How much? 63. So simplify this carefully. Is that correct? You should get 63 centimeters per second. Centimeter per second. 63 or 64? What you are getting here? 9 sixes. How much? 9 sixes. 54. 9 ones. 144. This will be 144. You get 144 centimeter per second, and then this will be 63, I think. You're getting in a reverse this thing. This is your V1 or V2? This is our V2. This is V2, right? Okay, okay. They have taken, first one is having 2 centimeter radius. We have taken that as the second one. So we are getting the, in the reverse way. This is supposed to be 63, guys. On simplifying this, we'll get 63, not 144. Okay. V1 is 63 only. Yes, R.S. Sanjay. Yes, correct or no? Yes, yes. V1 will be 63 and V2 will be 144. So V1 is 63 centimeters per second and V2 is equal to 144 centimeters per second. Just without simplifying this time, I mentioned this as just by looking into this options. So we have to simplify carefully and do it. Okay. So simplify this yourself and carefully do it. This is how we have to do it, guys. Similar kind of question is given the next one also. So question number 44 is also exactly the similar one. Let's do it. Try this yourself. But here in the next question, they have given it as a perfectly inelastic collision, not elastic collision. So it is given that next question. Let us do after this. Let us do the next one. Let us do the next one. Question number 44. Question number 44. So it is given that a steel ball of radius 2 centimeter initially at rest, it is stuck head on by another steel ball. I have to take this as R1. Steel ball of radius R1 is equal to 2 centimeters. Initially at rest, its velocity is um, okay, is 0. Hmm? Then it is stuck head on. It is stuck head on by another steel ball of radius. Let us say R2. It is equal to R2 is equal to 4 centimeters. Traveling with velocity of same value they have given. U2 is equal to 81 centimeter per second. Okay. Then common velocity. The common velocity, if it is perfectly inelastic, if it is perfectly inelastic, that means if v1 is equal to v2 is equal to v, what is this common velocity if it is perfectly elastic collision? Then we should follow that v should be equal to m1 u1 plus m2 u2 by m1 plus m2. Here u1 is 0, this term becomes 0, so then you can write m2 u2 by m1 plus m2. So m2 u2 by m1 plus m2 is common velocity, but masses are not given, radii are given. Then you can write as mass is proportional to radius cube, so you can write r2 cube e2 divided by r1 cube plus r2 cube, and substituting these values, r2 cube is 64 into u2 is 81 divided by r1 cube is 8, 2 cube is 8 plus r2 cube is 64. What is this? 64 into 81, this is how much? 72, 72. Yes, this on simplifying, how much we get? Yes, 63 or something else, the similar kind of the above one, right? What is that? 56 into 81 by 72 there we got. Here 64 into 81 by 72. Hmm. So simplify this. Other students, if you see in the chat box, there is a message. This is a virus message, guys. It's a virus. Don't click on that. And if anyone is possible, try to report that message, guys. Try to report that. Now just at 9:43, I got one message in the chat box. It is a virus related one. Don't click on that. Try to report that. Report that. If everyone reports, then you will not receive this kind of messages. Report it. Report it as a spam or something like that. So what is this then? So what is the answer for this, guys? What is the answer for this? What is the answer for this? Did you simplify, everyone? Right, very good, Anna, very good. So it should be equal to 72. Is it 72? Yeah, centimeter per second. So therefore, the final common velocity is v is equal to 72 centimeter per second. Similarly, Similarly, based on this, there are a few more questions are given based on elastic and inelastic collisions in 1D in exercise level 1, exercise 1 and 2. So let us do some questions now. Level 1, exercise 2. Level 1, exercise 2. Level 1, exercise 2. Yes, guys. Yes, question number 41. Next. So level 1, exercise 2. So question number 41. Page number 42. 42. So what is given here? Let me read the question once. So those who are not having the volume, you can go to the question and write down the data and write the question also if possible. You can pause the screen and you can write the question carefully. So the question is, a ball of 4 kg mass moving with a speed of 3 meter per seconds has a head-on elastic collision with a 6 kg mass initially at rest. The speeds of both the bodies after collision are respectively. Options. So no need to worry about the options. This is the question. You can directly try. So let us try to write the given data by reading the question once again. A ball of mass 4 kg. Let us take it as initial mass. M1 is equal to 4 kg. Moving with the speed of, let us take it as initial speed of first one. Moving with the speed of 3 meters per second, has a head-on collision with a 6 kg mass. Let us consider this is M2 is equal to 6 kg mass, which is initial head-on collision with a 6 kg mass, which is initially at rest, means U2 is equal to 0. And speeds of both the bodies after collision, if the first velocity of the first one after collision is v1, velocity of the second one after collision is v2, what are these you are asked to find if they are elastic collisions. So you have to remember the direct formula. We know that v1 is equal to what? M1 minus M2. Yes, you can try this, guys, everyone. M1 minus M2, M1 minus M2 by M1 plus M2 into U1, right, plus 2 M2 by M1 plus M2 into U2 into U2. This is further and substituting this here, u2 is 0, so this entire term will become 0. So we can write this is equal to, substitute the values, m1 minus m2. M1 is 4, m2 is 6, 4 minus 6 is, directly can write down values, minus 2 divided by what? M1 plus M2, 10 into U1 is 3, so 2 5s, so 3 by 5 minus 3 by 5 minus 3 by 5. So what will get? Minus 3 by 5 means minus 0.6 is equal to minus 0.6. So V1 is equal to minus 0.6 meter per second. So this is V1. If you see the options, minus 0.6, there are two options are there with this. So you have to calculate the V2 also to clarify this. What is this? Plus 0.6 2.4 minus 0.6 2.4 minus 0.6 minus 2.4 minus 0.6 minus 2.4. Two options have repeated here. Okay. So second and fourth options are repeated. You have to just take this carefully, guys. Then the fourth option, you can take it as with plus 0.6 minus 2.4. That's it. Okay. Okay, right. So anyway, v1 have got minus 0.6. What is v2? Let us try to find out what is v2. V2 is, this implies v2 is equal to Also v2 is equal to 2m1 by total mass into u1 plus, already have got this expression, right? M2 minus M1 by total mass into U2, that U2 term, U2 is 0, so this term can be taken as directly here 0. So this is equal to 2M1. M1 is 4. 2 into 4 is 8 divided by M1 plus M2 is 10 into U1 is, what is U1? 3. So what will you get? 2 fours, 2 fives is equal to 12 by 5. So 5 twos 10.5 fours 20. So 2.4 plus 2.4, right? It is plus 2.4. So we get V2 is equal to, therefore V2 is equal to plus 2.4 meters per second. So you have to select the options appropriately as per this, minus 0.6 and plus 2.4. So option 3 is the right one. I hope it is clear for you guys. Next, question number 42. Question number 42. What is given here? Question number 42. There is no need to do any calculations here in the next question. Let us see what is this. Question number 42. It is given that a ping pong ball strikes a wall with a velocity of 10 meters per second. If the collision is perfectly elastic, find the velocity of the ball after impact. A ping pong ball strikes a wall. Isn't it rhyme? It looks like a rhyme, right? A ping pong ball strikes a wall with some velocity of let us say this is u is equal to 10 meters per second. If the collision is perfectly elastic, it will bounces back, with the same velocity. So but because the direction changes, so you have to take this as minus u. So we can take the value is equal to, as the direction changes, you have to take it as minus u, or the velocity is equal to minus, the final velocity is equal to, final velocity of this is equal to v equal to minus u. So it is equal to magnitude is same 10 but in opposite direction. So you can take it as this is u is equal to 10 I cap, this v is equal to minus 10 or 10 minus I cap, so or minus 10 I cap. So it will be equal to minus 10 meter per second. V equal to minus 10 meter per second. No need to do any calculations here. That's it. Then next, similar to the question number 41. So he is given that two identical balls collide head on. The initial velocities of one is 0.75 meter per second, while that of the other is minus 0.43 meter per second. If the collision is perfectly elastic, then their respective final velocities is. Here, the second one is moving with velocity of minus 0.43 means in opposite direction. Here, the sign you have to take into consideration properly, and you have to find out, the final velocities. So try this yourself next. Right. Next question number 43. Let me read the question once again. Two identical balls collide head-on. The initial velocity of one is 0.75 meter per second, while that of the other is minus 0.43 meter per second. If the collision is perfectly elastic, then their respective velocities, final velocities are. So let us write down the given data. Two identical balls means m1 is equal to m2 is equal to m, or let us write it as m1 is equal to m. Let us write like this. M1 is equal to m and m2 is also equal to m. They are identical, having same mass, and they're initially having the velocities. The initial velocity of the first one is u1 is equal to 0.75 meters per second, and initial velocity of the second one is u2 is equal to minus 0.43 meter per seconds. Okay, if the collision is perfectly elastic, what is v1 and what is v2 is the question. So you have to substitute substitute these values in the formula for elastic collision. For elastic collision, you have to say, for elastic collision, v1 is equal to, write down this, m1 minus m2 by m1 plus m2 into u1 plus 2 m2 by m1 plus m2 into u2. Substitute the values. This is equal to, what is m1? M1 is m, m2 is also m. So m minus m becomes 0. So as they're identical, this term will become 0. Okay, so no need to calculate that. So that is equal to 0 plus 2m2 by m1 plus m2. So m plus m, 2m by 2m, 2m by 2m gets cancelled, u2. So what is u2? What is u2? Just here we have to just remember that if you, the one of the special case, if two identical bodies collide elastically, their velocities will interchange, if you remember that point, no need to do this even what you call calculations also. Simply you remember this, you remember this statement, guys. Just I would like to even delete this. You can try to remember this statement. Write down as a note. Write down as a note. Yeah, write down as a note. For elastic collision, comma, for elastic collision, write down this as a note. For elastic collision, if two identical, if two identical bodies collide, collide, if, if two identical bodies collide, or you can say if two identical bodies collide elastically. Okay, if two here you have taken as for elastic collision, you have taken, right? This sentence formation meaning will change. If two identical bodies collide elastically, you can just keep this in a box. So you have to take, you have to start the sentence from here. If two identical bodies collide elastically, then their their final, they collide elastically with velocities u1 u2, something like that. If you say, if you take their final velocities, their final velocities will interchange, will interchange. That is, if first body is moving with the u1, the two bodies 1 and 2 are moving with u1 u2, then final velocities become, you can take the diagram, then it will be a little more clear for you guys. If this is m1, this is m2, wait. This is m1, this is m2. It is moving with velocity u1, this is moving with velocity u2, maybe in opposite direction also. Here it is in the given negative, means in opposite direction it is moving. This is before collision, if they collide elastically, so that if this is m1 and this is m2 and their final velocities are v1 and v2, in elastic collision the velocities will interchanges, means velocity of the first body after collision will be given to this, will be given to the second one. That means u1 will be given to this, so v2 will be equal to u1, and this will be given to this, will interchange. That means v1 will be in elastic collision. Okay, then take care everyone, bye bye. I hope it is clear, right? Yes, guys. As the network was disconnected for a few seconds, just I would like to repeat this solution once again. As if two identical bodies collide elastically, then their final velocities will interchange. That means the final velocity of the first body will become the initial velocity of second one, and final velocity of second body will be initial velocity of the first one. So here initial velocities u1 u2 values are given 0.75 minus 0.43. So v1 will become u2, that is minus 0.43 minus 0.43, and v2 becomes u1, that is plus 0.75 meter per second. That's it. Okay. Okay then. Take care everyone. Bye bye.